Hello everybody and welcome to another installment in the Learn to Pi series. Today we'll be taking a look at loops. In this episode we'll touch on while loops, for loops, the range function, jump statements, and list comprehension. So let's start with what a loop is. A loop, otherwise known as an iterative statement, is essentially a block of code that repeats a known or unknown number of times. These are the two basic types of iterative statement or loop. When you know how long a loop is going to last, it's known as a definite loop. But when you don't know how long it's going to last, it's known as an indefinite loop. What this all basically means in layman's terms is that if you have a block of code that you want to repeat a certain number of times, you can do it using a loop. In programming, loops are super useful when you want to complete a repetitive task multiple times, or if you want to access multiple elements inside of another element. So we can do that using loops. Starting off with while loops. While loops work in a very simple way. There is a syntax using while. You have a condition, a colon, and then you have some code that you want to repeat. What this basically means is that in Python, if you want to have a block of code that you repeat given a condition, so given that a condition is true, given that a number is greater than another number, given that some statement that you've created is true, or given some other condition, the loop will repeat over and over until that condition is no longer met. So while something is true, do this. And then if it's still true at the end of the code block, then go back to the beginning and do it again until it's no longer true. That's basically what a while loop is. So let's create one really quickly just to show you an example. So let's create a block of code really quickly, and let's define a number. Let's call it num1. Let's say it's equal to 0 for now. And now let's create our first while loop. And let's say we want this block of code to repeat until number 1 is no longer smaller than 10. So as soon as number 1 is greater than 10 or is equal to 10, this condition is no longer met. This condition is no longer true. So this loop will repeat while number 1 is smaller than 10. That's basically what we're saying here. And while number 1 is smaller than 10, what we want to do is we want to print number 1. So we want to see what value number 1 is. And we want to increase number 1 by 1. So we want to increment it by 1. So we want to say number 1 is equal to itself plus 1. And let's go through this really quickly just to see what's going to happen. Let's try and make a prediction. So number 1 starts off with the value 0. Then we enter the while loop, and the condition is that number 1 is smaller than 10, which is true because number 1 is currently 0. What this is going to do is it's going to put us into the while loop. So we're going to execute this block of code, and then we'll check against the condition again at the end. So first we print number 1, so we'll print 0, which is the current value of number 1. Then we're going to say number 1 is equal to itself plus 1. So number 1 is equal to 0 plus 1, so it's going to become 1. Now we go to the beginning of the while loop again, and we check for that condition that we had earlier. So is number 1 smaller than 10? Well, the current value of number 1 is 1, which is smaller than 10, which is true. So then we continue and redo this block of code. So we print number 1, so we print 1, and then we say number 1 is equal to number 1 plus 1, which is 1 plus 1, so we'll get 2. Is 2 smaller than 10? It sure is. So we print 2, and then we add 1 to 2, so we get 3. Is 3 smaller than 10? It sure is. We print 3, then we add 1, so 4. Is 4 smaller than 10? Yes, print it, and so on until we reach 10. So let's say it's 9, we add, and since 9 is smaller than 10, we'll enter this loop. Then we'll add 1, so it becomes 10. Is 10 smaller than 10? It sure isn't. 10 is exactly equal to 10. So we will no longer enter this loop. Again, we will not print 10, we'll just exit this area and we'll go into a new area. Whatever comes after the while loop is what we're going to do. So let's run this code and see what happens. So what we should expect is it to print every number from 0 to 9, but not 10, because the condition wouldn't be met, wouldn't be sufficient for us to enter the loop a final time. So let's see what happens. And as you can see, we print all the numbers from 0 to 9. Just to show you something interesting, if you create a while loop, note that the while loop will not stop unless the condition is false. So if we just write while true, we'll actually get an infinite loop. And I'll just quickly run this to show you that this will run forever. So you'll just get a bunch of infinites printed out. Let's really quickly explore why this is true. When we enter a while loop, we first check a condition. So true, well, that just returns true. So we enter the loop, we print infinite, and then we go to the beginning. And since this will never change, it's not a variable, and it doesn't change during the runtime of the code block, this loop will go on infinitely. And this can mess with your memory. So make sure that you check in your code if you're accidentally creating an infinite loop or not. I'm just going to run this just to show you guys what it's like. And it'll just keep going forever. So as you can see, it's not stopping, and I will have to interrupt this not to break my computer. But eventually, yeah, eventually this will cause some issues in your code. So just be wary that this can happen. We can do the same with false. So if you see, we'll never actually enter this loop here. So let's say we print false here. This will never actually be printed. Let's print something else here. Let's say print else. I don't know. Let's go through this. While we'll check the condition false, returns false. Since this condition isn't met, we'll just skip over to this case over here. So this will never actually print false. It'll just print else. And my IDE has kind of faded out this text. You can see it's never going to happen. And you see we don't print false, we just print else. So I wanted to show you a really cool and common use for a while loop. So let's say we have a password that we want our user to input. And let's say we have a minimum length for our password. And so we're going to use a while loop, and we're going to say while the length of the password is smaller than, let's say, 8, for example. And we're going to prompt the user to write the password again. We're going to say, we're going to print, and we're going to use an f string here. We're going to enter the password here, variable, and we're going to say password is too short. Please input a new password. There we go. And once we exit this loop, we're going to print the user's password. So print your new password is, and then the password variable. So let's see what happens here. Let's run this. What we should expect is that we ask the user to enter the password. If that password is smaller than 8, the length of that password, so how many characters are inside it, then we'll enter the loop. We'll print password is too short, so the variable, the password, whatever the user enters, and then we'll prompt the user to enter a new password again. And if we exit the loop, so if the password has a length greater than 8, so if there are more than 8 characters, then we'll say your new password is, and then the password. So let's run this and see what happens. So right now it's prompting me to enter a new password. So let's enter something like ORB, which is only 3 characters long. Let's see what happens. And it says orb is too short, as you can see here. So I'm going to enter something else like Python. Python is also too short since it does not have 8 characters. Now let me write AorbTech. And AorbTech does have more than 8 characters. So it exits the loop and it says your new password is AORB. Okay, that's pretty cool. So let's see what happens if we, from the first pass, we enter a password that already has 8 characters. So what we should expect is, since it already has 8 characters, we never actually enter the loop, and we just print the new password. So let's run this one more time, and let's enter AorbTech again, since we know that that has more than 8 characters, or at least 8 characters, and let's see what happens. So as you can see, we never get this text because we never enter the loop. We just get this text at the end. So we kind of skip over this whole code block here. And we just get your new password is AorbTech. So that's pretty cool. So let's say you want to iterate over a list. Let's say we create a list here. Let's say list1 is equal to, and then we'll have a list inside. I'll have a couple of elements, let's say year 1, year 2, year 3, and so on. You can see how this would go. Let's say year 4. We'll do up to that. And now let's say we want to go through each of these. Remember that a list is made up of a bunch of elements inside, which each are accessible using an index, right? So if we wanted to access, let's say, year number 3, we know that indexing starts from 0, so this would be the 0th element, this would be the first, and this would be the second. So what we want to do is we want to print using the list1 variable, and we want to access it at position 2, because that's the third element. And we're going to print that really quickly, see what we get, and we get year 3, which is what we were expecting. So if we wanted to access each of these, we would need to access each of them at their indexes. So 0, 1, 2, 3. Notice how each index is 1 greater than the last. And we can use loops, basically, to have an index variable. We're going to start it at 0 since that's the first index, and let's say we increase it by 1 each time, and then we print the element each time, so at that index. So let's create a while loop here. Let's say while index is smaller than the length of list1. Since we don't want it to go past our limit, we know that if we were to try and access this at position 4, even though it says year 4, we know that this element would be at position 3 since indexing starts from 0, so we shift everything by 1 to the negative direction. If we try to access this at position 4, we would get an error. So let's make sure that we account for that by not exceeding that limit. We're basically saying while the index is smaller than the limit, which is 4 in this case. And what we want to do is we want to print the element, so list1 at position index, since we know that'll be the element we're trying to access. And what we should expect is when I run this loop, it is going to print year 1, year 2, year 3, year 4. So the element at position the index. So the index is 0, and then we increase it by 1, and that's the key thing here. We need to say index is equal to index plus 1. So this increases each time the loop runs. And so we go back to the beginning of the loop. It's still smaller than 4. Let's say it's number 1 now. We print at position number 1, so year 2. Then we increase it by 1. The index is now 2. We go to this condition, is it smaller than 4, since that's the limit again, remember? And so it is still smaller. We print list at index position 2, so year 3. And then one more time we increase it by 1. We get 3. It's smaller than 4, so we print the fourth element, or the element at position 3, index equals 3, which is year 4. And then finally we increase it by 1, it'll be equal to 4, and 4 is not smaller than 4, so we'll exit the loop. And so let's run this just to see what we get. And yeah, we print every single element in the list. That's pretty cool. So let's take a look at for loops. What is a for loop? Let's try and explain it in a simple way. A for loop in Python visits every element or every item inside of an iterable object. What is an iterable object? An iterable object is something that has more than one element inside it. And a for loop allows us to access each of those elements one by one in a specific order. It has this kind of syntax, which is for item in iterable object, and then the code that we want to repeat. So this code will repeat for every item in iterable, or in the iterable object. This could be a list, it could be a tuple, it could even be a dictionary or a view object, and it can also be a range, which we'll take a look at in the next part, in the next section. So let's say we have a list here. I've created a list containing the spelled out first 6 numbers starting from 0, so that's 0 to 5. And let's say we want to print each one of these in the list. So each one of these strings here are an element of an iterable object. This list is an iterable object because we can iterate over each of the elements inside it, each of the items inside it. So let's create a for loop here. And let's say for number, number in numbers, and numbers is the name of the list we have here, and then we'll put a colon here. What this is essentially saying is for each of the variable number, so we're creating a new variable to reference each of these elements. This is referencing, for example, 0 or 1 or 2 or 3, depending on where we are in the loop. So for each of these elements in the list, numbers, and this is the list here that we have defined, and then we have a block of code that we're going to repeat for each of those, so for each of the numbers. So let's say now we want to print, and we want to print number. And remember that number is a variable we've created in the loop which references the element that we are currently viewing inside the list numbers. So since we're referencing, let's say, the first element, it should print 0. And since this is going in order, it'll then, at the end of the loop, go back to the beginning and it will say, are we at the end of this iterable object? No. We still have yet to finish. So let's go on to the next one, which is 1. Then we print it. We go back to the beginning. Have we visited until the end? No. So let's print 2. And we carry on printing each of these until we reach the final element. Then we'll print that final element. And since we're at the end of the iterable object, we're going to finish the loop and continue to whatever code you might have afterwards. So let's run this. We should expect that each of the elements is printed one by one. Now let's see what happens. As you can see, each of the elements from 0 to 5 has been printed. So remember in a previous episode, we said that we can access the elements inside of a dictionary using a view object. So we can look at them in the program if we want to, but we can't actually access them. We can do this using a for loop. So if we write for, I've created a dictionary here with names and surnames. And so we'll have for, and we have the key and the item here, or key value. Let's use this terminology. In name, surname, and that's the name of our dictionary. And we're going to print, and we're going to say we're going to create an F string. We're going to say key, and we're going to add a colon there, and then value. And so what we're doing basically here is let's create dot items. So we're accessing the dot items of the dictionary, the items of the dictionary, and remember this returns a view object. We're saying for each key value pair inside that view object, and we're separating them into different variables here. And then we're going to say for each of those, execute this code. And what this code does is it prints out the key on the left, followed by a colon, followed by the value on the right. So what we should expect is for each of these to be printed, each of these name surname pairs. So let's see what happens when we run this code. And as you can see, we can indeed access each of the values inside of this view object using this for loop. So as you can see, these names are being printed out. Very cool. So let's talk about the range function. The range function is a very useful function in Python. It basically returns a sequence of numbers. That's it. It follows this format, so range, start, stop, step size. So this is the range that you want to visit. This is from the beginning to the end, non-inclusive. That's another thing to note. And you don't actually need to write start and step size. Those are optional. You can just write stop, and it'll automatically write from 0 to the stop number, so to the end number. And this can be useful in lots of different situations when you need to access a specific sequence of numbers in a specific order, following a specific rule, for example. And I'll show you how you can use it below. Let's really quickly look at the simplest example that we can with the range function. So let's create a for loop. Let's say we're creating a variable value for value in, and then we use the range function, and let's say 10, right? So we put a colon and we print the value. What is this doing? What does this mean? First of all, we're creating a for loop. So when we create a for loop, we know that we're going to iterate over some kind of iterable object, and we're going to store each of those elements in each iteration of the loop inside this variable value, right? So this variable represents each of the elements inside this, whatever's over here on this side, right? So range, what does that return? That returns an iterable object with a sequence of numbers. So it returns the next number in a sequence each time, starting from a specific number. In this case, we're doing the range with the parameter 10. What this basically means is the numbers from 0 to 9, since this is non-inclusive. So what we should expect is, since this represents each of the elements inside of this, iterable object inside of this range function, what we should get is the values from 0 to 9. And since we're printing each of those values in each iteration of the loop, each pass of the loop, each time we go through the loop, each time we go through each of the elements, we should expect to print in order the numbers 0 to 9. Let's see what we get if we actually run this code. We get exactly what we described. Each of these represents an element in this object here that we get, in this iterable object. So what range basically defines is a series of numbers, not a list. Don't get it confused with a list. It's a separate entity from that. It is an iterable object that returns the next element in a sequence of numbers. In this case, we start with 0. The next element would be 1, then 2, then 3, all the way up to 9, since that's what we defined in the beginning. Remember that 10, that's non-inclusive, so it's all the numbers up to 10, but not including 10. So let's look at some extra examples of this. It can seem a little daunting and difficult at first, but it's actually super easy as long as you understand what's going on. Let's try using more parameters. So let's create a for value in range, just so we get used to this, in range, and then let's say we want to access the numbers from 18 to 65, and we want to step by 1, right? So then let's print the value, and what do we get? All the numbers from 18 to 65, not including 65, remember, not including 65. Let's do a new code block. Let's create a for loop, and we want to access the values in the range. And let's say we want to print all the even numbers from 0 to 10. So starting from 0, and since we want to include 10, let's say 11, because that's the first number after 10, and it's not going to be included as well. And since we want to print the even numbers, we should step by 2. So let's see what this looks like. Of course, we want to print the values. Oh, and that's what we get. So 0, 2, 4, 6, 8, 10. Awesome. So now that you know kind of how the range function works, I've created a list here with all the ordinals in English up to 5. So first, second, third, fourth, fifth, right? And let's say we want to print each of these. So for value in range, and let's say since we want to access the items in the list, let's instead call this index, because we'll be referencing the index of the list, right? So for index in range 0 to 5, right? Since we know there are 5 elements inside of this list, and we want to access from 0 to the fourth, since indexing starts from 0, we'll index in range 0, 5, and you should know that by default range uses 1 as the increment value. And we're going to print the value of ordinals, so that's our list, at the position index. There we go. So, what does this mean? Let's take a look at this. We're iterating through the values 0 to 5, and we're storing that in a variable index, not including 5, so 0 to 4. And then we're printing the list at position index, so 0 to 4. We're printing the list at those indexes. So the values, the elements at the indices 0 to 4. So those are the first 5 numbers. What this means is that we're going through this list and we're printing each of the elements basically from the positions 1 to 5. Or if you remember that indexing starts from 0, 0 to 4. So let's actually run this and see what happens. And as you can see, we get each of these printed out. So let's quickly take a look at another example. I've taken our numbers list from the previous examples. I'm going to start another code block for index in range. So again, this means that we're creating a variable called index, and we're doing it in a specific range from one number to another number. So we're visiting all the numbers in a sequence. And now we need to define the sequence using the parameters for range. Let's say we want to access the first 4 of these. So there we go, we put in 4. And what we want to do is we want to create an f string here, print, and we want to print the index. So we want to see what this value is. and we want to see the element in this list. So we're going to print numbers at the position of index. So we'll get to see what the index is, and then what the element is of the list here using that index. So we'll get to look at both variables, and we're doing this for the first 4 elements. Let's print and see what happens. So we get 0, 1, 2, 3. Those are 4 elements. We can increase this up to 5 or 6, since there are 6 elements. Let's see what happens. We get 4, 5. If we try and do any higher than that, let's say 7, then we should get an error. Since we're trying to access elements that do not exist in the list. We go from the index 0, 1, 2, 3, 4, 5, and then we try to access the 6th, because this is non-inclusive, remember, so it's all the numbers up to 7. So we do 6, and since there is no 7th element, or an element with the index 6, we get an error here, an index error, which basically means that we try to access something outside of the range of this list. So jump statements are a special kind of statement that go inside our loop that allow us to fulfill extraordinary situations. So let's say we want to skip over a specific iteration, or if a specific condition is met, we want to end the loop entirely, but it doesn't have to do with the original condition that we have for the loop to end, so we just want to add that in there as well. Or let's say we want to have something that happens if the loop never starts to begin with. So these are some extra things that we can add to spice up our loops. Let's take a look at else. Let's say we have a while loop here. Let's say num1 is equal to 0 first of all, and let's say while num1 is smaller than 3, print num1. First, let's increment it. So num1 is equal to num1 plus 1. Oh, and another way you can write this. So there's this statement here. Let's comment this. You can say num1 plus equals 1. So these two statements are equivalent. So this is the same thing as this, basically. Each time we increment num1 by 1, and then we print num1. Now let's put an else here. And let's print over. Well, let's print false for now. Let's just print false. What this is basically if the condition is not met. Let's see what happens if we run this really quickly. You can put your guesses in the comments below. So as you can see, we go through the loop normally. We go from 1 to 3. So since we're incrementing first, num1 is 0, but since it's smaller than 3, we enter the loop. First we increment it, so now it's 1, then we print it. And then we keep doing this over and over until we reach 4, at which point we print, once we finish this block of code in the while loop, we continue to this block of code here, this else statement, and we print false. So what this else basically is it's a block of code that happens when this condition here is not met. That can be at the beginning of the loop, or it can be at the end of the loop. But when this condition isn't met, we finish doing this code, and we move on to this code over here. Okay, this one is super useful. This is break. Let's say at some point during the loop, we want to check if a certain condition is met, and if it's met, we want to stop the loop entirely. So let's create a for loop really quickly. So for value in range, let's just say we want to visit the first 10 numbers from 0 to 9. Or maybe let's spice it up from 1 to 10. And we want to say print value. And let's say if value is equal to let's say 7, we want to break. And what this is going to say is we want to print each of these values, and then we're going to check for this condition. If value is equal to 7, then we break. So we exit the loop. And let's quickly just see what happens. Let's run this. and we get 1, 2, 3, 4, 5, 6, 7. So we go all the way up to 7. So as you can see, we still print the value. We go through all of these, and then as soon as we notice that the value is 7, we exit the loop. So we never actually get to end up printing the rest of the values. So that's really cool. It's really useful in a lot of different situations. Continue is similar to the previous two, or similar to the previous one, except it continues the loop, it just skips a certain scenario. So let's create another loop. For value in range, and let's say 15, why not? Now let's say we want to print every one of these values except for those divisible by 3, right? So let's quickly say if value mod 3 is equal to 0. And what this basically means is this operand here gives you the modulus of the 3. So let's say this was a quotient, we would get the numerator. Basically what we're saying is if the operation of dividing the value by 3 gives us a remainder of 0, so no decimal points, then we should continue. So we should skip over this iteration. And then we're gonna write print value. So if this code executes, we're gonna skip this iteration of the loop, right? And this block of code, in layman's term, just means if value is divisible by 3, if it is a multiple of 3. So if we have a multiple of 3, skip this iteration and go on to the next one, right? And for every other iteration where it's not divisible by 3, we print the number. So let's see what happens really quickly. And as you can see, we print 1, 2, but 3 is nowhere to be seen. We go straight to 4, 5, then 6 is missing, 7, 8, 9 is missing, 10, 11, 12 is missing, 13, 14, 15 is missing. So we print all of the numbers except those divisible by 3. So that's a really cool application of this statement. Okay, this one is mainly useful when you're writing code and let's say you don't have enough time to finish it, so you need to pack it up for a little bit, but you don't want it to cause any errors in the meantime while you're doing other code. So you move on to something else, and you don't have time to finish this code. So let's say you just have a for statement here. Let's say for value in range 5. So and let's say you have some idea here like print each of the values or something like that, and you don't have time to implement this. If you try to run this code by itself, it'll cause an error. It'll cause an error which will mess up the rest of your program. It'll cause a lot of issues. So what you can do here is you can use pass. And what it'll do is basically saying, okay, so I want to have a for loop, and I'm going to put some stuff in here eventually, but for now it's kind of empty, but I don't want any errors to happen or anything like that. So I'm just going to put this pass statement here, and what your Python will do is it basically says, okay, we'll let you free on that one. We're not going to cause any issues, but you've got to implement it in the future, all right? So this is kind of just like placeholder code. Like you'll put something in here eventually, but right now you just don't have anything in there. So list comprehension is something super useful that I don't see in enough tutorials online. So a lot of newcomers to Python, they won't know how to use it, but it's super useful. And it's basically a simple way of creating lists with predefined values. Let's say we wanted to create a list with just a bunch of zeros inside it, like specifically 10 zeros or 15 zeros or however many zeros you want. Or let's say we wanted to create a list with all the numbers from 1 to 100, for example. There's no like intuitive way to do it, right? So this is just a really cool way of doing it. I'll show you how to do this. Let's say we have a limit here, or let's say we have a size, let's say, and that's going to be equal to, for now, 10, right? What we're going to do is we're going to say zeros is equal to, we'll create a list, so whatever's inside of these brackets will become a list, and let's say 0, because that's the value we want to do, for let's say value in range, and then the size, whatever the size is that we created. What this basically means is that we're gonna put in the value 0, and we're gonna do it for every value in this range, and then let's print zeros, and let's see what we get. And as you can see, we get a what I would call an empty predefined list. So it's a list with just a bunch of zeros inside of it, and you can set these to whatever you want. And this follows a specific format. As you can see, we have an output here. This is what we get. This is what we get as the actual value of each of the values. We get a range, kind of like you could say, you could use another list as this, for example, and then you have a condition at the end, which we didn't put in this case. Let's create one with a condition here. Let's say we wanted to create every even number from 0 to 10. So let's say even 10 is equal to, we'll create a list here, and we're going to say value. So we're creating a variable value here for every value in the range 0 to 10, and since we want to include 10 and it's non-inclusive, we'll write 11. And we could do it like this. We could use a jump statement. Let's just see what we get using that, or a jump parameter in our range. And let's print even 10. See what we get. So we get all of the even numbers from 0 to 10. But let's say we don't want to use this parameter. We could say if value mod 2 is equal to 0. And again, this is just the remainder. So if the division of value by 2 gives us a remainder of 0. So if the value is even, and since we have this condition, now if we try running this, we should get the same result, all the even numbers from 0 to 10. So let's say I have a list here, and I have a list of fruits, right? Let's say I wanted to get every fruit that starts with a particular letter, right? So let's create a new list here. Let's say starts with, and then let's pick a letter, I don't know, let's say A, for example, starts with A, is equal to list, and let's say value for item in fruits, or let's say item for item in fruits. So we're creating a variable item, and it's going to be the elements in fruits of the list fruit. And then let's say if item dot starts with, and this is a function you can use for strings, and let's say A, right? And maybe just to make this more understandable, let's say fruit instead of item. So if for each fruit in the list fruits, we want to add it to this new list if this condition is met, which is that the fruit, the variable that we're checking, so the element inside fruits, starts with the letter A, right? Let's run this and see what we get really quickly. Let's also make sure that we print the new list. So it starts with A, and let's see what we get. And as you can see, we have a new list with elements or with fruits that just start with the letter A. And let's quickly go through this. We get apple here, we have apricot, and then we have avocado. And as you can see, those are the ones that we have in our new list. So this is a super useful tool that you can use in your programming. So that was the Learn to Pi video on loops. If you enjoyed this video, like, subscribe, share it with others, share the joy of programming, the joy of coding. It is a gift to be able to code in the 21st century. This is what runs the world. If you like these kinds of videos, we have a Python video we're uploading weekly. We have other series that we have planned that you can go check out maybe at the time of the time this video has been uploaded. We have a number of different websites and repositories and resources for you to learn from and to practice with. If you want to see these kinds of videos, if you want to know when we upload so you can learn with us, so you can try some new skills, then ring that bell icon because it'll keep you updated. It'll keep you notified on whenever we upload new videos. I hope you have a lovely day. I hope you enjoyed this video, and I hope to see you in the next one. Bye-bye.